Have you guys experienced wind tunnels here in Halifax?
Maybe here or here or maybe here.
Aren't they so annoying?
Not just are they uncomfortable, they're also a safety hazard and discourage active transportation. Active transportation is healthy, affordable, environmentally friendly, and reduces those busy 5 p.m. traffic jams.
So imagine someone with a disability or your grandparents walking around. Imagine how frustrating that can be in Halifax rainy weather. So the real question is, how can Halifax Regional Municipality can address these sneaky tunnels? Let's take a look what other places did.
First off, Hong Kong recommended a handful of urban design solutions to improve wind conditions, specifically porous podiums, but also landscaping and mixed density. Hong Kong has a similar context to the Halifax Regional Municipality Urban Core, in that it has an abundance of high-rises and little open space in between, as well as increasing land prices and population. The case study by NG et al. Focused on a small problematic area known as Mong Kok. They depicted the surface roughness of urban Hong Kong using a mapping method that takes into account the forms and the site wind availability. Working with a GIS team, the map provided city planners with a way to understand urban ventilation for decisions related to air paths, urban permeability, and city porosity. The study concluded that compact development and podium structures with large ground coverage on extensive sites particularly negatively impact air movement and should be avoided where practical. Additionally, breezeways should be created in major open ways.
Accessibility case study, temperature and rain moderated the effect of neighborhood walkability on walking time for seniors in Barcelona. It was conducted in one of the largest and most urban places of both Southern Europe and Spain. 227 seniors were sampled, with 44% being men, 52% were women, and all of them were either 75 above or 75 below the age, and the variables were considered things such as temperature and rain. As we all know, seniors need an active lifestyle. By having one, it provides numerous benefits such as reducing cardiovascular diseases and can be used for socializing. Walking is as well the most accessible form for seniors in order to have a physical activity, as it is the least demanding for their bodies. Therefore, it is important to have accessible spaces for them to use, and the built environment plays a critical role. However, not just land use, but walking highly depends as well on both individual and environmental factors, such as if it's sunny outside or if it's windy. The term walkability can be referred to a given place that is friendly or aggressive for pedestrians, such as in safety or the comfort of the area. Walkability can also describe the capability of the environment in allowing walking trips on an everyday basis. This study was conducted in Barcelona, Spain, where 227 seniors were sampled, ranging under and over the age of 75. 52% of the seniors were women and 44% were men. The study took two main variables during the walkability assessment: temperature and rain, which the variables that primarily affected seniors. The case study used information relating with either temperature and rain from governmental weather stations. Each senior was asked to have a GPS for 7 days. Barcelona was particularly chosen due to being one of the most urban places within both Southern Europe and Spain, with over 5 million people living within the city. The methodology included in most walking data were collected from the GPS that seniors cared for 7 days. The participants in the research study were provided as well with an accelerometer in order to record the intensity of their physical activity during the 7-day period. The study found that most seniors did not mind the cold temperatures, which was surprising, in that the rain was the one that affected walkability. There was a total of 14.8 minutes of daily walking as the median. Those who live in far more walkable areas spend their time more walking than those who did not. The temperature-wise of 25 Celsius was the median. Studies show men tended to walk more than women. Despite the results of the case study, there were still some major weaknesses. It did not take into consideration any seniors who had some form of disability, such as visual impairment or a walk-in disability. Thus, the same lens in terms of walkability cannot be applied to every senior. Therefore, other terms of accessibility need to be taken into consideration.
Secondly, San Francisco recommended solutions to improve the effects of wind on pedestrians' sense of comfort in public open spaces. San Francisco's high-density urban core experiences notable wind tunnels, which impact pedestrians' perceived comfort. In an effort to improve this, San Francisco adopted a downtown plan in 1985 on ground-level wind currents to reduce the negative effects of wind on pedestrians' comfort in public open spaces. A study conducted by Kim and McDonald 30 years after the plan's initial adoption looks at its effectiveness and provides further recommendations for improvement. The study used wind tunnel simulation using scale models of 4 key regions of the city known for their high density development, high wind speeds, and large volumes of pedestrian traffic. The wind speeds had dropped by 22% since 1985. However, there were still remaining problem zones, so the study developed a number of recommendations to improve wind comfort in these zones and other municipalities alike. These recommendations include designing tall buildings to have protruding lower-level podiums, deep canopies, screens and fences as windbreaks, as well as interdisciplinary bridging between urban planners and urban climatologists, and citywide wind monitoring for evaluating problem zones. These can be used to improve wind comfort in cities that have cool climates, where wind reduction would improve pedestrian comfort.
But what did we learn? We learned 4 key lessons. Number 1, no one left behind.
Number 2, once buildings are in place, it's harder to reconstruct them to reduce their wind impacts. This is why we should focus our efforts on proactive design.
Number 3, such as weather conditions that can discourage people from walking.
Number 4, a collaborative approach across fields is required. However, these case studies, like any, have their limitations. The first being, there is no guide on how to incentivize developers.
There's no cookie-cutter solution. Solutions vary from country to country, province to province, and city to city.
Or there is a lack of data for seniors that have disabilities.
How can we apply these solutions to the Halifax regional municipality context?
First and foremost, we recommend the municipality continues to require qualitative and quantitative wind assessments as part of the development approval process for developments with lower surroundings.
The municipality should suggest podiums and canopies to developers who do not meet the wind required assessments.
Second, we recommend policy incentives for mixed density, especially in the urban core.
The municipality should also lead by example and incorporate more landscaping in the pedestrian zone. This will also add to the sidewalk's aesthetic and improve air quality.
All of this must be implemented using an integrative approach and an accessibility lens.
With these measures, pedestrian safety, comfort, and incentive to walk will improve.
And we can get rid of Halifax of these annoying wind tunnels.
For all!
Thank you for watching!
And now we want to hear from you.